So as it has been driving this particular thing, the alternating voltage can be written as an A is equal to V naught sine of omega t. This is an AC voltage or at any instant, AC voltage is this one. At the same thing, at any instant, AC current that is I can be written as an I is equal to I naught sine of omega. Okay, so where this I naught can be written as an, and that is the peak value is equal to this is V naught by R, where V naught is called as a peak value and I naught is called as the peak value of the current and peak value of the voltage. Okay, so the next important thing, as this has been continuously changing cycles, in the sense any AC current, whatever is there, it will be changing according to the time with respect to the positive cycle and the negative cycle. So like this, it will be flowing, and this is the maximum or the peak value, which is positive I naught value, and this is your, in case this is your negative cycle. Minus. So this is called as a one cycle completely. Okay. So since it has been changing continuously over there, the average value of AC over half cycle is so it's going to be how much? Because for a complete cycle, average value will be equal to the 0. So over a half cycle, we will be calculating. So that is an average value is going to be I average is equal to 2 I naught by pi, or this is equal to the 0.637 times of I naught. That is a peak value. For the V average, the same thing can be written as a 2 V naught by pi, which is equal to the 0.637 times of I. Right, Andy? So now coming to the average value of this curve. So as we have got the average value for a complete cycle, you can have that is RMS value of AC. What is this RMS value of an AC? It is called as a root mean square. The root mean square, or you can also call it as an effective current effective current, that is IRMS, is equivalent DC that will produce the same average. In the sense, IRMS value can be written as an, this is I naught by the root 2, and 1 by root 2 value is 0.707 times of I naught. Similarly, you can also have the VRMS also equal to the V naught by root. So V naught by root 2 value is also 0.707 times of V naught. So these are the two averages of current. So equivalent DC that would produce is an equivalent RMS value is an equivalent DC value which will produce the same average conditions. So same average, right, sir? So if you want to have the relationship between them, that is IRMS can be written as an I average into pi by 2 root 2 Or you can also have that this is VRMS, V average 5 by 2 rho 2. Okay, sir. So this is the basic. Now in this one we'll be using the phasor diagrams here. What do you mean by phasor? Yes. Phasor is the graphical representation. It is the graphical representation of the phase relationship between two or more quantities. Okay, so this is called as a phasor diagram. So V naught and I naught are represented as an actually the V naught and I naught are represented as vectors. Okay, so how does it going to be affected for a first case? That means in a circuit, if only resistance is there, and to the resistance, if you connect an AC source, so how does it going to be begin? So there is a circuit and there is only a resistance over here, and to this resistance we are connecting simply an AC source here. So that means we are providing V is equal to V naught sine of omega t. So what will happen in this thing? So the graph or the line of the phasor diagram for this case is going to. So if the potential graph is going to be extended up to some point, that means if the black arrow mark is going to be representing the V naught, then this blue arrow mark will be representing your current, I know. So they'll be on the same line. There won't be any phase difference between the input and the output region. ఎటువంటి phase difference ఉండదు. So that implies your current equation I is also equal to the I naught sine of omega t. And average is going to be the V average is equal to this is V naught into I naught by 2. Or nothing but this is equal to the VRMS into IRMS. VRMS into IRMS is the same. In the same situation, in the circuit, if in the circuit there is only inductor is there. So if only an inductor is being connected in a circuit like this, so in the sense, for example, this is an inductor. Okay, an inductor is being connected here. This is your N, and it is being connected to an AC source, where the input that we are giving is going to be the V is equal to V naught sine of omega. Okay. So then how it's going to be behaved? Since the provision given or the input voltage is equal to V naught sine of omega t can be written as an induced EMF dI into di by dt is equal to V naught sine of omega t. On solving, you will be getting I is equal to I naught sine of omega t minus pi by 2. That means current I lags the applied voltage by pi by 2 in an inductor. So you can say the both the ways. And correspondingly for the inductor reactance is inductive reactance, which is given by XL is equal to omega L, or else omega can be expanded in the further case, and power, that is average power, will be equal to 0. Okay, so this is the condition for a what concern when only inductor is being connected in a circuit. Now in the case C, that is if only capacitor is connected in the circuit. Capacitor is connected. So in the to an AC input, if only a capacitor is being connected, that is like this. It is a capacitor to parallel plate I am taking, which is connected to an AC source here. Okay, so now in this one, we are giving an input V is equal to V naught sine of omega t, and this is yours. So now what will happen in this case? So as we have given the V is equal to V naught sine of omega t, and the potential drop across any capacitor can be written as a, it is Q by C is equal to V naught into sine of omega t, and differentiating with respect to the time, differentiating this one with respect to time, then you'll be getting the current I is equal to I naught sine of omega t plus pi by 2. So in the sense, what is the meaning of this one? That is a current I in the capacitor leads the voltage by pi by 2, that is Vc. So in this case also average power is equal to 0. Remember this point. Power will be dissipated only across the resistor. It will not dissipate in any other case. So the frequency of your V naught, or then voltage across the capacitor and current across the capacitor, both of them are same. So this will be the situation. Now if we look at the phasor diagram here, so in the phasor diagram for the inductor is going to be like this. So I'm drawing here. So inductor phasor diagram we are just trying to draw here. So it is an that is, this should be the IL, and this will be the VL in this direction. Whereas for the capacitor there is a 90 degrees variation. So if I try to draw here, this is the direction of the VC, this is going to be the IC. Okay, so next there will be obviously the combinations of the circuits. One is an RL circuit, that is an resistance, and an inductor circuit. If a inductor and a resistance, LR circuit, this is L and R, both of them are connected to an AC source of V is equal to, this is V naught sine of omega t. Then the equation of the current will be I is equal to something, it will be changing. I is equal to, but not exactly, the phase difference will be minus pi, it cannot be the pi by 2, there will be some sort of a phase. So seriously, there is a current I lags only. I lags behind V. Okay, this is the basic thing. and phi should be in the radians. In this case, what is the thing that is called as a, suppose if I name it as a resistance or a, okay, as we have done the capacitor, let me write also this one. That is a capacitive reactance, which is nothing but the XC is equal to 1 by omega. So why do we call in the different names? The resistance unto now. The resistance offered by the inductor is called as an inductive reactance. The resistance offered by the capacitor is called as a capacitor reactance. Okay, so if I call every resistance with the same name as a resistance, so it will be confused. So the total resistance offered by the LR circuit or the combinations of the elements is called as an impedance. Impedance is nothing but it's the resistance of the total circuit. Represented by the Z, it will be root over R square plus omega L whole square. Or you can write it as an R square plus XL square. So now since the resistance is there will be a power, average power or the power loss will be there. That will be the equal to the V naught by root 2 into I naught by root 2 into this is cos phi, or it is equal to the VRMS into this is IRMS into R by root over R square plus XL square. Okay, and the phase difference for the LR circuit is going to be phase difference that is formula for the tan phi. So the tan phi can be written as n, which is equal to the omega L by R. How did you get this? If I plot a graph for the LR circuit, since the resistance voltage does not change, it will be here. For the inductor, voltage will be along the y-axis. So there is a phase difference over there. So this is your resultant of both of them. So which makes an angle phi, and this resultant, since both the vectors are perpendicular, then it will be the VR square plus VL square. If I write the total potential as the same thing, if I write the total potential as the same thing, that is V is equal to root over VR square plus VL square. Since both of them are in the series combination, same current will be flowing. So I into Z is equal to root over I into R whole square plus I into XL whole square. If I cancel the I, then your formula for the impedance is equal to R square plus XL square. That's the same thing that we have written. Okay, this is the Z value here we have written, which is called as an impedance. Right, sir? On the power dissipation, we have discussed. This is the general thing, and now we can go for an IRMS is equal to VRMS by Z, where Z is called as an impedance. So if the same sort of a thing we will be writing the CR circuit, that is RC circuit or anything. Okay, so that is a capacitive and a resistance. So how does this capacitance and a resistance circuit is going to be there? So this is your resistance and this is your capacitance C, and this one is going to be the R. So they are jointly connected in series to a voltage source, that is V is equal to V naught sine of omega t. Now this has been connected here. So since this is a relation, the phasor diagram for this one will be looking like this. This will be the VR direction where it will be along the positive x-axis only. And this will be your VC. This is going to be your resultant. The root over, that is VR square plus VC square. Okay. So based upon this one, we can say that VRMS is equal to the root over the same thing, that is VR square plus VC square. from this one Z, which is nothing but an impedance. Impedance is equal to root over, this will be the R square plus XC. XC can be written as an 1 by omega C, so that can be written as there. And tan phi is equal to, that is the phase difference. Tan phi is equal to XC by R. So this is your phase difference, and in this case, voltage lags the current, or the current leads the voltage conditions. So AC has an average value generally 0 from the 0 to the time period T. So variation of the current is a periodic in nature, as well as we have seen. It's a sine curve, positive and negative sine lo vastundana, cosine sine curve avasam ledu, cosine curve shape lo kuda undochu. And alternating current at any instant in the T is nothing, is being provided by V is equal to V naught sine omega T, which is called as an instantaneous conditions. Right, sir? Now your last type of the third type of the circuit is called as an LC circuit. That is an inductance and this one LC series circuit. So what is this LC series circuit, sir? When an inductor and a capacitor are connected into an AC source like this, are connected to an AC source in this way. So if I plot a phasor diagram, the phasor diagram will be like this. In this direction, you can have the IRMS or anything like this. It is the direction of your VL and it is the direction of the VC. There is a phase difference of the 180 degrees. So given input is equal to V is equal to V naught sine of omega t. So current produced will be I is equal to I naught sine of omega t plus or minus. Why plus or minus? If inductance is dominant, then it will be the minus. If capacitor is dominant, then it will be the plus. And potential drop across the inductor can be written as an I into XL. Similarly, potential drop across the capacitor can be written as an I into XL. And we know the values of the XC and XL, where XL is equal to XL is equal to integration and omega N, and XC is equal to 1 by omega. Okay, so these are the conditions of where VC is going to be greater than the VL. If VL is greater than VC, it leads by 5 by 2. If VL is greater than VC, it lags by 5. And resultant voltage can be written as an resultant voltage V is equal to, that will be the VL difference VC. That means greater value minus smaller value you can do. Now impedance of the circuit, that is Z, can be written as a root over. Obviously it will be cancelled. This will be the XL minus XC whole square, or else you can remove that one, which is XL minus XC. Okay, sir. So in this case, if at all, in this case, if XL is equal to XC in this situation, then Z becomes 0. That is, the impedance of the circuit will be 0. We're coming across that XL is 0. What is the condition for that? Here another type is going to be the LCR series circuit. What is this LCR series? The resistance and an inductor or a capacitor or an inductor. So R, C, L are all three of them are connected to an AC source like this. So in this AC source, what we are giving as an input is V naught sine of omega t that we are giving. And what will be the phase change here? So this is the direction of your VR and this is the direction of your VL. and this is the direction of the VC. If I reverse the direction, this will become minus VC, and the combined V will be written as a VL minus VC. So two vectors are VL minus VC perpendicular, then the resultant will be equal to the V, makes an angle phi. Then V can be written as a root over VR square plus VL minus VC whole square. So now applying the current in this relationship, that is I into Z, I term will be cancelled. So Z is equal to root over R square plus XL minus XC whole square. And the phase difference tan phi can be written as an XL minus XC by R. This is how he's going to measure this, but that is tan phi value. Okay, so these are the very important relationship concerned to this one. Coming to the power over here. So as I have told you, power will be lost only across the resistance. So this will be the VRMS into this is IRMS into that is cos phi. Right, sir. So this phi is called as an or cos phi is called as an power factor. This cos phi is called as your power factor. This is a very, very important thing. That is, power factor is defined as a generally true power by apparent power. That is, power factor is equal to power factor, that is cos phi, whatever it is equal to how much? True power by that is apparent power. Apparent power. So this is the condition. From the same relation, cos phi can be written as an adjacent side by Z. Or this is R by Z value is going to be root over R square plus XL minus XC. This is the situation. Right, sir. So now the most important thing in this one is if XL is greater than XC, it behaves as an or the LCR behaves as an inductive circuit. Inductive circuit. Next case, if XL is less than XC, it behaves as a capacitive circuit. Okay, so this is the thing. Inductance equal to inductive. Yes, so third case is the most important case, please. If XL is equal to XC, then it is called as a resonance. When XL is equal to XC, that means it is in the resonance. Z will be equal to the R. Since XL minus XC becomes 0, Z is equal to R. And I, that is that current reaches to maximum. Okay, so XL is equal to XC and omega L is equal to 1 by omega C kada. Ante omega square is equal to 1 by LC అయినప్పుడు frequency is equal to 1 by 2 pi root LC. Okay, na? So now in this case, power factor will be equal to how much here? Power factor. Okay, now that is the power factor in this particular situation. That is cos phi is equal to the adjacent side R by Z. And Z value is also equal to the R, then cos phi is equal to 1. Since cos phi is equal to 1, phase difference is equal to 0. Right, sir, and the total potential here is equal to when XL is equal to XC, it will be root over VR square plus VL minus VC whole square. It is your total potential in this case. So this happens only at the resonance. And another most important formula that you need to remember is different formulas. That is Q. Q means what's the quality factor. So what is this quality factor or the Q factor is XL by R in the sense which is equal to the omega L by R. So or else it is also can be written as an XC by R lo kuda raskochu. That means 1 by omega C into R. So like this, what does this quality factor actually explain? Quality factor is more than the quality of the that is an inductor, the sharpness or the current thickness will be sharp. So that will be benefited by. Okay, Nana? Next case in this one, we can go for that form factor. What is another formula? Form factor. So what is this form factor mean? Which is equal to the IRMS by I average. IRMS by I average, it will be almost, it will be remains constant 0.707 times of I naught by 0.637 times of I naught. Then it will be the 1.1. Okay, so this is the condition, sir. Now, next one is called as an admittance. The reciprocal of the resistance or impedance is called as an admittance, 1 by impedance. Okay, so this is your admittance under Nana Jagrata. Reciprocal of the reactance is called as a susceptance. Okay, there will be another different things. Next topic is the transformer. What is this transformer? Is a transformer is a device which can convert from the low voltage to high voltage or reverse or and vice versa. So అంటే రివర్స్ కూడా అవుతుంది. దీని నుంచి ఏం రాసుకోవచ్చునా? That is an potential of the secondary by potential of the primary is equal to number of turns in the secondary by number of turns in the primary, which is equal to the current in the primary by current in the secondary, and this will be always remains constant. That is secondary into Vs is equal to Ip into V. Okay, so if in this case, if number of turns in the primary is greater than the number of turns in the secondary, then it is called as a step down transformer. Right, sir? Next, ఒకవేళ FP is less than NS కనుకైతే step up transformer. Okay, so step up transformer and step down transformer, these are generally widely used in the different conditions. And the efficiency of the transformer can be written as an efficiency of a transformer, which is represented by the eta is equal to output power by input power. Okay, so this is the basic conditions. Output power by and an input power. So generally for a generator, if you go for this one, AC generator, so it moves in a circular manner where the EMF can be written as a E is equal to omega B A n into that will be the sine of omega t, and this represents your peak value, that is E naught omega B A n. Right, sir? So these are the conditions generally working for the different parts of an AC circuits or the efficiency of a transformer, or so these type of the things will be seen. Right, sir? So please be careful. Another one. What is the choke coil? Choke coil. What does the choke will do in a tubeless? In this case, in it or else in AC, it works on the principles of what, sir? So that is self-inductions. Self-induction. Right, Anna? So an oscillating dipole of radiates electromagnetic waves. Next one, direction of propagation. Direction of propagation in the sense of this anything particular wave. You can take it in specific conditions, but ikkadaithe idi pedaga use avvadu. You can remove this particular thing. Okay, you can use it for another waves which can be movable from one point to the other. Right, Andy? So these are the very important points regarding this one. Let's go for the first question here. In the figure shown, 3 AC voltmeters are connected. They are in the resonance. Resonance from the antenna. XL is equal to XC ne kada. Ante XL minus XC 0 kada. Ante ఈ రెండింటి దగ్గర potential గా if I multiply with the current this one, I into XL minus XC 0 nena, which is nothing but the V2 is equal to 0. So this is your first one. Next is the square root of inductance and capacitance. LC should be equal to the actual formula is frequency or omega is equal to 1 by root LC kadandi. Omega is equal to 1 by root LC. Mundu question anana. Teeskondi. Now can I go for the next question, please? Right, Nana. So omega is equal to 1 by root LC అయితే దీని నుంచి LC root LC value ఎంత లెంగ్త్ అయితే కాదుగా మిగిలింది. The only thing that can happen is going to be the sun. Okay, so next one. Next in this one, please. So in a transformer 200 volts AC, that means voltage in the primary is equal to 220 volts. Voltage in the secondary is equal to 2200 volts. If the number of turns in the secondary, that is NS, is equal to 2000, the number of turns in the primary, NP by NS is equal to VP by VS. Directly proportional. Number of turns in the primary kavali, NP by 2000 is equal to primary 220 by 2200 goes for 100 times. Okay, or goes for 10 times this one. One of the 0 will be cancelled. Number of turns in the primary will be the 200 turns. Right, Anna? Next question, please. A step down transformer. Step down ante number of turns in the primary will be greater than the number of turns in the secondary. The primary coil AC 4 amperes and the value of the current and the potential is asking in the secondary. Okay, so this is the situation. So now for this one, how to calculate this? Number of turns in the primary by number of turns in the secondary is equal to voltage in the primary by voltage in the secondary. So substitute the values, sir. 500 by this is 5000 is equal to primary voltage is equal to 220 or 2200 volts by voltage in the secondary. Okay, these two things goes off. Here also these two things we can remove, and this goes for 1000 here. So Vs is equal to 22 into 10 to the power of 3 which is 22000 volts. So there are the two options are there. Next, we need to find the current. Number of turns in the primary by number of turns in the secondary is equal to current in the secondary by current in the primary. Since the power input power will be equal to the output power, the earlier aspect. So this is going to be the 1 by 10 is equal to current in the secondary by 4, which is equal to the IS is equal to 4 by 10 in the sense it will be the 0.4 amperes. So 0.4 and 2200 results. Next is step-up transformer operates on an step-up transformer operates on a 230 volts line and supplies an 2 amperes. The ratio of the primary and the secondary windings are in the ratio. Current in the primary adugutunnadu. So number of the turns in the primary by number of turns in the secondary are 1 by 25. So which is equal to the current in the secondary by current in the primary. So 1 by 25 is equal. Current in the secondary step-up transformer operates supplies 2 amperes. Current in the primary adugutunnadu, this is 2 amperes by IP which is equal to the 50. Next, transformer efficiency, that means 80%. 80 by 100, that is eta is equal to, that is output power by input power. Output power in the sense you can take it as an Vs secondary into Is by Vp into this is Ip. 80 by 100 in the sense this will become 4 by 5 is equal to the voltage in the secondary is equal to 200 and next one sir, the transformer with efficiency 80% works at 4 kilovolts and 100 volts. So that means your 100 volts is going to be the primary. Here we don't have the Is and Ip. So for that one, power in the primary is equal to voltage in the primary into current in the primary. 4 kilowatts means 4000 is equal to 100 into Ip. So these two things goes out from this one. Current in the primary is equal to 40 amperes. Substitute there, this will be the 40 and we need the value of Is. Now go for the solving sir, this one. This goes for 2 times. So that is 80 by 5 is equal to Is, which is equal to the 16 amperes. So if the primary and the secondary currents are, one is 60 amperes, 16, other one is going to 40 amperes. Okay, he has asked the primary, that is secondary. Then your answer should be first option rather than your second option. Next one. The value of an alternating EMF is given in the circuit. So what is the value of E? E is equal to, just now we have written, root over it will be the VR square plus VL minus VC whole square. So substitute them please. VL minus VC. So VR square means 80 square 6400 plus VL minus VC 100 minus 40, that is 60 square, which is 3600. Now on adding these two things please, that will be the 100 into 10 square, or get it outside, this is going to be the 100 volts. The input that we have supplied is going to be the 100 volts. In a series LCR circuit, voltage across the resistance capacitance, that means he has given VR is equal to 10, which is also equal to the VC and which is also equal to the. Then your total potential difference can be written as a VR square is plus VL minus VC whole square. So since both of them are the same, output voltage is equal to VR only. So this is the initial conditions, and output voltage is also equal to the 10 volts. Now the capacitance is being short circuited, means capacitance is being removed. Since capacitance is being removed, voltage across system can be written as an simply VR square plus that will be the VL square. And both of them are equal to the same values. What is asking, sir? Sorry. Potential across the inductor he is asking, so VL square. Okay, let me substitute the values here. Total input is going to be the 10 square, that is 100 is equal to VR square. That means VR square or it's 10 ilanim cheskunte. VR and VL are going to be the same. It is 2 into VL square. And from this one, VL is equal to 10 by root 2 volts. This is your situation, sir. Next one, in an LCR circuit shown, the impedance is going to be how much? Impedance means is asking the Z. Z is equal to root over R square plus XL minus XC whole square. So let's first find out the XL and XC values is equal to how much? XL is equal to omega L. So input value they have to provide XC is equal to 1 by omega C. We do have the L value and this one also we are having. Suppose if I take the frequency or your that is 2 pi here omega let it be, actually the frequency in the Indian circuits will be the 50 Hz. It's a common stuff basically. So if I put that one and substitute omega can be written as a 2 pi into 50 into inductor is 1 Henry, which is equal to the 100 pi. And next one 1 by 2 pi into C, which is 20 into 10 to the power of minus 6. So this can be written as a 1 by 4 pi. This is 10 to the power of 5. Okay, so these are the information basically that we have here. So or else you can also divide with them take 2 and solve. So now XC, XL we have got, so we need to substitute here. The resistance is equal to 300 square plus XL minus XC 100 pi minus 10 to the power of 5 by 4 pi whole square. So this is your impedance, that is Z. And the last one of the today's is a 220 volts 50 hertz AC generator is connected to an inductor and a resistance in series. Current flowing through the circuit is I is equal to 1 amp. What is the potential difference across the inductor? Potential difference across the inductor is I into XL. I we have got here, that is 1 ampere. XL we need to calculate. XL is equal to omega L. Omega means 2 pi F. F is 50. That is 100 pi into inductor. So he is asking the potential difference across the inductor itself. So this much current is being flowing. Inductor value is going to be something as an here. Or else we do have the current and we do have the voltage, then we can find the resistance R is equal to V by I, that is equal to the 220 by 1. So resistance R is equal to 220 ohms. Okay, so inductor connected to inductor and the resistor, sorry, this is 50 ohms, this one. So if I remove this one, 22 by 5, which is nothing but a 4.4 ohms, this one R value. So in from this one, what is the potential difference we need to take? This is going to be the one inductor value, that is inductor and 50 ohms resistance are connected. Inductor value he has not provided. But from this one, you need to find out the Z from here, because Z is equal to V by I. V is equal to 220 volts by current is 1 ampere. Z is equal to 220 is equal to root over. Okay, this is going to be the R square plus XL square. R value 50 substitute chase XL at the concoach kada. So from this one, substitute the XL here. You can get the VL value is going to be how much? Right, sir. So these are the general questions that will be asked, please. So I will be closing the today's session.